Hello everyone, welcome back to the channel. Today we're going to be looking at solving linear inequations. It's called linear for the reason that the highest power of the variable is 1, right? So these equations or inequations would produce a straight line on graph, and that's where the term linear comes from. So whenever you have an equation or an expression that in which the highest power of any variable in that equation is 1. So this is x to the power of 1. That's a linear equation or linear inequation or expression. Now it's called an inequation because it's not equal to anything. You'll see either one of these 4 signs instead of the equal sign. So it's not equal. So it's either greater than or equal to, which is different from just being equal to, right? Less than or equal to. So these in mathematics are what are called inequations. Inequation signs. Alright, but we pretty much solve the inequations, in the same way as we solve equations, with one main exception, and I'll show you when we get to that, where it has to do with dividing by a negative number. So if you end up with your final answer having to divide by a negative number, what you're going to do is reverse the inequation sign, or the answer will not make sense. So that has to do with dividing by a negative number in your final answer. So hopefully we'll see an example of that. But other than that, the idea when solving whether equations or inequations is to isolate the variable. And if you have like terms, put the like terms together, simplify the inequation, and still try to isolate the variable in the end. So get everything else on the other side and the variable on one side, preferably the left side, and preferably a positive variable. Right? So try and work with the x, the y, the b, whatever the variable is. Try and work with that on the left and bring everything else to the right. And in order to bring them to the right, what we do is the opposite operation of what we were given. So if we're adding a number and we want to cancel it out, we do the additive inverse. We subtract the same number from itself to get 0. And we have to do the same thing on both sides so as to balance the equation or inequation, so we don't really change it. We're not really changing it. We're just using the convenience of the additive inverse principle to get rid of that number from the side you don't want it. So we're going to see all of that in action, right? So we have x plus 5 is greater than 9. What is x? So we want to isolate the x. We want the x by itself. It's on the left, that's where we want it, and it's positive, that's how we want it. So all we need to do now is to get rid of the 5. So we're going to do the additive inverse. We're adding 5, we're going to subtract 5, so that becomes 0, and we have to do the same thing on both sides. So x is greater than 4, right? X is greater than 4. So plugging this back into your inequation, it makes sense, right? If you add 5 to a number and you must get something that's greater than 9, the number that you're adding to 5 must be greater than 4. Because if it's equal to 4, you're going to get exactly 9, right? So if you want something that's bigger than 9 as your answer, whatever you plug in here must be bigger than 4. Okay, makes sense, right? Alright, so y take away 4 is less than 20. We're going to do the additive inverse of subtracting 4, which is to add 4. And we add 4 to this side. So y is less than 24. Okay. If you want a number that when you take 4 from it, you get less than 20, your number must be less than 24. Because if it's exactly 24, you're going to get exactly 20 if you take 4 from it. And if it's more than 24, you're going to get more than 20 if you take 4 from it. So the number that you put here must be less than 24. That's the logic of it. Here we have, it's the same term, but we have more than one. It's the same variable, sorry, but we have more than one terms having that variable, so we need to group the like terms. So, what we can do, since if I bring the 2p over here, I'm going to end up with p minus 2p, which is negative p, which I'm trying to avoid. So I prefer to let the 6 stay here, and I'm actually going to take p from both sides, right? So that cancels out and take p from that side. So I have 6 is greater than 2p minus p, that's p. And now I'm going to add p to both sides. Add 2 to both sides. So I have 8 is greater than p. Or if I want to rewrite it, p is less than 8. Same thing. These are the two same things. 8 is greater than p, so p is less than 8. Okay? Alright. So we have negative 5p plus 8 is less than or equal to 40. Alright, so we have a negative p. Alright, so we have negative 5p. We could bring it over, but let's work with it here. We're going to take 8 from both sides. So that's 0. So we end up with 32. Now to get p, we need to divide by negative 5. But remember I said when you're dividing by a negative number, you have to invert the inequation sign. So that cancels out. So it's going to be greater than or equal to, and that's negative 6 and 2/5. So always remember, if in your final stage you end up having to when it's time to isolate the variable by dividing by the coefficient of the variable, if it is a negative coefficient, remember you are to reverse the sign. So it's not p is less than this, p is greater than negative 6 and 2/5. Alright, so that's what I was talking about. See, we ended up having to divide by a negative 5 to isolate the p. We need to reverse the inequation sign. 6 times what must be less than 36. Alright, so we're going to divide both sides by 6 to isolate the x. So x must be less than or equal to 6. Right? If we're multiplying x by something to get less than 36, if we're multiplying 6 by something and the answer must be less than 36, that number that we're multiplying by 6 must be less than 6 in order for the answer to be less than 36. If it is exactly 6, then the answer will be exactly 36. So it must be less than 6. Here again, we're going to end up having to divide by a negative 4 to isolate the y. So we know that we are to reverse the sign. So y is less than or equal to negative 4. Right? Alright, so 2x plus 6 is greater than or equal to x minus 9. We have two terms with the same variables. We're going to group the terms. So I'm going to take the positive x and bring it over here. I'm actually taking x from both sides, right? At your level, grade 10, you don't actually have to show this step, these steps that you're taking that from both sides or dividing both sides by that. You can just actually do the operation. So we can just put 2x minus x. We don't actually have to show this. So I'm showing you so you see what we're doing. But at grade 10 level, you don't have to show that. So we have 2x minus x and negative 9. So this x, this 6, we would be taking 6 from both sides. So we'd end up with negative 9 minus 6, and that 6 would be, with the additive inverse, would cancel it out. 6 minus 6, that would be 0. So we're taking x from both sides, and we're taking 6 from both sides to group the terms. So here we just end up with x, and here we have negative 15. So x is greater than or equal to negative 15. Now we have a bracket, and we have a number in front of the bracket. So that tells us we should be using the distributive law to expand the bracket, and then we're going to simplify if we need to. Well, it's only going to be one term, so we don't need to simplify. We're expanding the bracket using the distributive law. 4 times 3x, that's 12x. 4 times negative 1, negative 4. Now we're going to add 4 to both sides, so this will cancel out. And we're going to end up with 50 plus 4, which gives 54. Now we're going to divide both sides by 12. That cancels out, so we end up with 54 divided by 12. So that will be 4 and 6 over 12, so that will be a half. So 4 12 is 48, and 6 remain out of the 54. 6 over 12, which is a half. X is greater than 4 and a half. Here now we have fractions with inequations. We are going to work the fractions just as how we would work regular fractions. So we're going to find the LCM. We're finding the LCM so that we can have all terms over the same denominator. And once we have achieved that, we can actually just focus on solving the numerator because they're all over the same denominator. So the common denominator of 3, 4, and 6 will be 12. 3 goes into 12 4 times. 2x times 4, that's 8x. So we know that's over 1. So we can put in the 1 just to remind ourselves. 1 goes into 12 times, and 4 12s are 48. 4 goes into 12 3 times. 1 times 3, that's 3. And the x. 6 goes into 12 2 times. 2 1s 3. They are all over 12. We can, for all intents and purposes, ignore the denominator. They are all over the same denominator. We can focus on solving the numerator. So we have 8x minus 48 less than or equal to 3x minus 2. So grouping the like terms, we're going to be adding 48 to both sides to cancel that out, and taking 3x from both sides to cancel this out. That's how we're grouping them, right? So we're going to have 8x minus 3x, because when we take 3x from here, that's gone. When we add 48 to both sides, this is gone, and we'll have negative 2 plus 48. So this gives 5x, and this gives 46. So now we're going to divide both sides by 5. So x is greater than or equal to 5 into 46, 9 times, remainder 1 over 5. And finally, our final example, another fraction. Let's put this over 1 to remind ourselves that that's a 1 there. And we're going to find the LCM of 9, 6, and 3, which is 18. 9 goes into 18 2 times. 2 2s 4, y. 6 into 18 3 times. 5 3 is 15. 3 into 18 6 times 616, and 1 into 18 goes 18 times. 18 times 4 would give 4 8s 32, 4 1s 4. So that's 72. Now grouping our like terms, I am going to take 4y from both sides so that that can cancel out and we'll have the y over here, because if I do the other way and take 6y, I'm going to end up with a negative y here. 4y minus 6y would give negative 2y. So it's all up to you, you have to manipulate the inequations to see the best way to solve it. I prefer to work with a positive variable. So once it's possible, I try to manipulate the inequation so that I end up with a positive variable. If it can't be avoided, then that's fine. We just remember that when we're dividing, when we have to divide by a negative coefficient, we are going to reverse the inequation sign. Just remember that. That's the only thing really if you're working with a negative variable. So I'm going to take 4y from both sides, and then I'm going to subtract 72 from both sides as well. So just doing all of that together, I would have 15 minus 72 greater than or equal to 6y minus 4y. Alright, 15 minus 72, so that would be 57. Let me check that. 72 negative 57, and this will be 2y. So now we'll divide by 2, both sides by 2, and that would be 2 into 5, 2, 2 into 17, 8.5. Or we can write it with the y on the left. Y is less than or equal to negative 28.5. Right, and that is our solution. Right, that's our solution. So remember, it's up to you. It's all up to you how you manipulate the situation. Right? See the best way that you can solve. If you can get a positive variable, all the better. If you end up with a variable that has a negative coefficient and you're about to isolate the variable, just remember you're going to have to divide by the negative coefficient, and you're going to need to reverse the sign. Alright? So if you have been helped by this video, just drop me a line in the comments to say thank you, and share the video as well so other students can benefit from the information. And if you haven't subscribed, do so now please. I'll see you in the next video.